Hi, chemistry students. So in this video, we're going to go over the answers to our periodic table review sheet. And I just want to point out, I am using a periodic table. All right, you should be using one at home. You should either print one out or have it open in a second tab. But I recommend printing out a periodic table. It's going to be incredibly helpful. You can use it on the periodic table assessment. So see how easy that's going to be. All right, so this first question, we want to label the group numbers, the energy levels, and then identify the following families. So the group numbers from left to right, it should be 1, 2, this section 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You should get 3 through 12 in the middle. 13, 14, 15, 16, 17, and 18. All right, the energy levels, it's on the left side. It's the rows 1, 2, 3, 4, 5, 6, 7. All right, so 7. These two bottom rows are extensions of row 6 and 7. But most importantly, the families, halogens, group 17. Here are the halogens. Alkaline metals, group 1. Alkaline earth metals, group 2. Transition metals, this whole middle of the periodic table, this lower section, and noble gases, group 18. Okay, so that element, guess who? Which element has 2 valence electrons and 3 energy levels? When I look on the periodic table, I'm looking in group 2. I'm looking in the third row. It is magnesium, Mg. Which element has 5 valence electrons and 4 energy levels? So now again, I am in row 4, and I'm going all the way over to group 15. It is As, all right, which is arsenic. All right, again, don't go to group 5 for valence electrons. Go to group 15 because we skip groups 3 through 12. And which element has 6 valence electrons and 2 energy levels? That is going to be oxygen. All right, it's in group 16, so 6 valence electrons, and it's in the second row. All right, define the following periodic trends. Atomic radius, that's just size, right? The atom basically takes on a sphere shape. The radius is from the middle nucleus to the outer electron. All right, so it tells us the size. If the outer electron is further away, it is a bigger sphere, it is a bigger atom. All right, so again, atomic radius, size. Ionization energy, the amount of energy to remove one electron. We remove the electron from the valence shell, all right? And again, ionization energy turns the atom into an ion by removing one electron and creating a positive cation. And electronegativity, the ability of an atom to attract electrons, all right? These are outside electrons from a different atom. Which trends correlate with the following periodic table? Increasing to the left, increasing going down. That is going to be atomic radius. All right, bigger on the left side, bigger as you go down. More energy levels and less protons in a given energy level. Which trend is this? This could be ionization energy or electronegativity, right? It is both trends. Ionization energy, larger on the right side of the periodic table. Electronegativity, larger near the top, gets smaller as we go down. All right, according to the trend for atomic radius, which element would have the largest atomic radius? All right, that'd be in the lower left. That would be francium. Which one would have the smallest? That would be in the upper right, helium. According to the trend for ionization energy, which element would have the largest ionization energy? It's actually the opposite of radius. The largest ionization energy would be all the way right and all the way up. That would be helium, right? So helium, smallest atom, highest ionization energy. Which one would have the smallest ionization energy? That would be francium. Biggest atom, smallest ionization energy. According to the trend for electronegativity, which element would have the largest electronegativity? All right, this would not be helium because the noble gases don't have electronegativity. They don't attract electrons because they have those full valence electron sets, so they have no need. So our next answer, according to that trend, it's actually going to be fluorine. All right, fluorine is furthest right and furthest near the top of the table and not a noble gas. Which one would be the smallest? That is going to be our francium. Again, the bottom, all the way on the left, lower left. Okay, arrange the following elements in order of increasing atomic radius. So from smallest to largest, we have magnesium, barium, and calcium. Explain your reasoning. Well, magnesium, barium, and calcium are all in group 2, right? The alkaline earth metal family. So the smallest element is going to be the element near the top of the group. It has less energy levels. So of those three choices, magnesium will be the smallest, then it will be calcium, and barium will be the biggest, right? Magnesium's the smallest because it has the least number of energy levels at 3, and barium is the largest because it has the most energy levels at 6. All right, arrange the following elements in order of increasing ionization energy, smallest to largest. We have carbon, fluorine, and lithium. These three elements are all in period 2. All right, so the trend in a period is ionization energy is increasing from left to right. So fluorine would be the furthest right, lithium the furthest left. So lithium has the smallest ionization energy, followed by carbon, and fluorine would have the largest. Explain my reasoning. Lithium has the least number of protons for period 2, energy level 2. All three of these elements are in period 2. All three of these elements have 2 energy levels. So lithium has the least number of protons, so it has the least attraction, so it's going to require the least amount of energy to remove an electron. All right, carbon has more protons than lithium, so it's holding its electrons tighter, so it's going to require more energy. And fluorine has the most protons in this period, in this energy level, so it's holding its electrons the tightest, and it's going to require the most energy to remove or to like pry an electron away. All right, and question 10. Which of the following elements would you expect to have the highest electronegativity? Silicon, chlorine, or aluminum? Explain. Silicon is Si, chlorine is Cl, and aluminum is Al. All three of these elements are in period 3. They are in the same period. The period trend for electronegativity is to increase from left to right. Which would I expect to have the highest electronegativity? The element furthest to the right, which is going to be chlorine. All right, but to explain, chlorine will have the highest electronegativity, the highest ability to attract electrons, because chlorine has the most protons in its nucleus for these third energy level atoms. Since it has the most protons, it is the most attractive, and so it will have the best ability to pull in outside electrons. All right, so hopefully these 10 questions have given you some good practice and they have helped you remember the material we have covered on the periodic table, and now you should be ready to take the periodic table assessment. So go take that, rock it, do a great job, and I will see you guys for our next unit on ionic compounds.